All right, so here, if we also show the attractions from the other nucleus, the one on the right, you can see that it's also pulling on both the electrons. So this is kind of where I was saying, like trying to walk a dog, right, that is attracted to the other dog, and they're pulling each other towards one another, and that's going to end up pulling the people, right, that are pulling those. So they end up being attracted to each other in this way, and you can see the line is showing that they are moving towards each other, right? You don't see these electrons moving in every direction. Now they're just kind of moving towards each other. Right, so this is a covalent bond. The atoms aren't really sharing electrons as much as they're kind of fighting over them, right? So they are both trying to attract the same electrons, but neither one can actually take them from the other, right? So this creates a situation in which both of them are kind of pulled together. Right, let's take a moment and look at what kind of atoms will form covalent bonds. So, in which region of the periodic table would you find atoms that attract electrons strongly? So remember, these over here on this side are giving away their electrons, which means these over here are pulling those electrons more, right? They're more electronegative. They are the electron hogs over here. So yeah, right here, you got it. Nonmetals tend to be good at taking electrons from other atoms, right? So these are more electronegative. They're the electron hogs. They hog the electrons strongly. So a covalent bond forms between two nonmetal atoms, right? So the covalent bonds will be forming between these atoms in this yellow part of the periodic table. Each atom attracts each electron. This pulls the atoms together. Right, so note that the hydrogen is considered a nonmetal and will form covalent bonds with the other nonmetals. Right, so this is the exception over here by itself on the left side of the periodic table. All right, and that's hydrogen. And so let's take a look at the covalent bond from another point of view. How is energy involved in the formation of a covalent bond? So here you see in the next few screens, we're going to look at the energy. So we're just going to try to move the nucleus in the right closer to the nucleus in the left, on the left. Right. And so try slowly moving the nucleus, and that's what we did right here. And you see the potential energy. Basically, it's saying that electrons want to try to get to the lowest point here, right? But if they get too close to each other, then that starts to go up, and that's not what they want. They want to be resting in this spot right here. This is when they're at their most stable, right? So this is why they go just a certain distance. And again, if you push them too close together, that potential energy, it starts going too high, and they want to be right here. They want to dip down as low as possible, and this is the distance that is required to do that, right? As far as they are from each other right here. So this is why they bond with the certain atoms that they bond with. So as the atoms move closer, the potential energy decreases. This is because each nucleus is attracting the other atom's electron more and more strongly. Right? And then after a certain point, the potential energy starts to increase if you try to move the atoms any closer. This is because the protons in each nucleus are now trying to push each other apart, right? So they got to get right in that sweet spot right here to reach this low point right here. If they get too far, it is not going to, it's going to be kind of high, right? It's moving up here. If they get too close, it's going to move back up again up here. Right, when atoms are arranged so that their potential energy is at the minimum down here, they're at the most stable, right? This is where they want to be. The stable balance between attractions and repulsions that are occurring. So again, it's that sweet spot between wanting to be close to each other and then start pushing each other apart. The distance between the atoms at this point is the bond length. So the point where the atoms are at their lowest, that's when they're their most stable, and that's what they're all aiming towards, right? This is, again, what they're all trying to do when they're bonding with each other. You're going to find that this idea is going to be repeated in other parts of chemistry, that the lower they are in energy, the more stable they're going to be. Right. And so when we draw pictures of molecules, we often use a single solid line to represent a pair of electrons. So here you have two electrons, you have one line. Here, when you have oxygen, for example, they share two pairs of electrons. So because there are two pairs, there are two lines. Right? This is called a double bond, and it represents four shared electrons. And then the nitrogen atoms, they share three pairs of electrons, and this is called a triple bond. It represents a total of six shared electrons. So this line represents two, the second one two, this third one two. So a total of six electrons, 2, 4, 6. Right, and these are from weakest to strongest. Single bonds tend to be the weakest of the covalent bonds. Triple bonds tend to be the strongest of the covalent bonds.